Oh, hello. We're going to look at number 53. We've got f of u is the sine of u, and u is this g of x function, x squared minus 9. And then we're looking for fog prime of 3. And that's kind of a funny way to say f of g. So this right here, that's a composition of functions, and that is the f of g. So the g of x is getting composed into the f function, so g is getting plugged in to f. Okay, so the first thing that I need to do is figure out the derivative. And if I'm taking the derivative of this, if I'm going to dx it, I'm going to have to use chain rule because I have one function plugged into another. So I'm going to do f prime of g of x times, so notice how I left the inside alone, I'm going to multiply by the derivative of the inside, g prime of x. And then it has us plugging in 3. So I'm going to evaluate at x is 3. Let's see what happens. We've got f prime of g of 3 times g prime of 3. Well, up here, I know that g of x is x squared minus 9, so g prime of x is going to be 2x. And what happens if I plug in 3 there? We're going to get 2 times 3, which is 6. So g prime of 3 is 6. So let's see, we've got f prime of, we'll have to figure out g of 3 also, right? And then times 6. G prime of 3 is 6. Okay, well, what's g of 3? Well, let's plug in 3 here. Let's evaluate when x is 3. So if I plug in 3, 3 squared minus 9, 9 minus 9 is 0. So g of 3 is 0. So I need f prime of 0 and then times 6. Well, I do know that f of a variable is equal to sine of that variable. So what's the derivative of sine? Cosine. Okay, so the derivative is cosine, so f prime here, we're looking at f prime is cosine, so I'm going to be doing the cosine of 0 times 6. And then I think about my unit circle, and right here at the 0 angle, 0 radians, also known as 0 degrees, we have that x is 1 and y is 0, and cosine is the x coordinate on the unit circle. So the cosine of 0 is 1, and then we're going to multiply by 6, and that's how we get out 6 for that problem. And in number 53, 6 was option C, as in candy, because who doesn't love candy? I hope you have a great day.